does it mean to do the inverse?
Opposite.
The opposite? Like,
According to
It's kind of like
opposite's a dangerous word.
you're taking the square root, you square it. If you're subtracting,
it's
adding,
kind of like undoing
divide,
what's done
multiply.
before. So it's
Yeah, you do the
Oh
reverse.
my god,
Undo.
I
Yeah, so
did
like
inverse functions before.
I
They're
know.
so horrible.
Not really. Now, I'm not saying that it should have been easy, but I am going to show you the ways to make it more manageable. So, you're absolutely correct. Inverses does the opposite, but be careful saying that because really what we're going to say is it gets us back to where we started or undoes something that has been done. So we are going to evaluate this first looking at function machines. So if you remember the function machine, it said if we drop an input value, excuse me, right, here's our x, into the machine our output value comes out. So the inverse function of this then would undo it and say if we drop 13 in, the inverse function gets us back to the original input.
Ambrose is a good name.
Right? Ambrose is a sweet name.
Ambrose.
So,
Versa.
think to yourself, what could be the function that turns 3 into 13? Then, what would be the inverse of it? So you don't have to agree with the people. Write your own function. Write your own function.
Is it really loud here when it's on?
I don't know if I'm
Because well, we can barely hear it when we're in the pod.
Oh, it hasn't really been storming today. Like a tiny bit, but not much longer.
Okay, because this morning.
So, hold up. I got some side conversations. I need us all to focus up. If we are trying to figure out a function that could do this, I heard a couple ideas. My function could be, I think I heard Owen say just add 10. My function could be, whoa, hold on, pause. What is going on?
Well, okay, so in 2020, they're going to put another middle school attached to us. And when you think,
Yeah.
who do you want to be attached to? We want you to think Worthington Academy.
You realize, thank you so much. You realize we're going to have zero say in this,
They're
right?
not even poisoned.
Yes, we are aware that there's no say on it.
So you guys are just trying to poison us so you can take over the whole building, is what you're saying?
I'll take
Or the
Or-
world.
I'll take it.
Yeah.
I'll take it.
Thank you guys so much.
I'll
Now,
test it.
wait, Claire, did you make these or did one of your students make
One of
them?
our students' parents made it, so it's even better than those two options.
Yeah, there you go.
How was it?
Remember the summer when we ate those muffins?
Those were that was hilarious because then
great.
Mia that's all sad. She wanted the muffin. She couldn't eat the
Okay,
muffin.
hold-
She waited
I'll
long.
handle it.
It's probably expired.
All right, hold up. Chris, you were saying?
3x plus 4.
I think that's
Huh?
I have the function of it.
Okay, well, I mean, both of those would work. We're just looking at options.
No,
What
I'm
else?
looking for a function considering negative for as well.
But yeah, okay, yeah, give it to me.
So, what I have is f of x equals absolute value of x times x plus 4. Plus 4. Like, if you put the absolute value of x times x.
So, yes, please. As opposed to x squared?
Yeah, because x squared, right?
But so we're not talking about negative 3. Are you paying attention to what we're doing, or are you in your own little space?
That's A though. A is axiom.
It is
Yeah, but so,
Good afternoon, AJ D'Angelo. Please stop at the office. AJ D'Angelo, please stop at the office. Thank you.
so we have a couple options right now. Oh, writer's up here too. I'm just trying to understand why you chose what you chose. You said absolute value of x times x, and then plus 4.
Yeah.
Okay, so then they tell us when 4 goes in, 16 comes out.
Now.
Would that work for our blue function?
No.
No. Would that work for our...
Yeah.
Yeah, that would work in our red function.
It also works for the other one.
It also works for green.
No, I mean the other. Oh, right. Input value.
So 4 times 4 is 16 plus... Ah, crap.
I mean, like.
So this guy's out. This guy's out. This is still working right now.
Yeah.
5 goes in. Or sorry, negative 3 goes in. Negative 5 comes out.
Yeah. Negative 9 plus 4 equals negative 5. Hey.
You think we got it?
Yeah.
So what could we write out then? Obviously this is a function, but if we say what to do to the input, like verbally, we want to write this out.
Multiply the input value by 3, then add 4 to that value.
So I'm going to be lazy. Triple
Okay, sure.
input. Sorry, my U looks weird. Then add, I know it got really tall. I'm sorry. So if we tried to say those instructions backwards, how would we say that?
Subtract 4 divided by 3. Yeah,
Subtract 4, then, right? Because we want to make sure that we still follow a specific order.
Wait, doesn't it say that Petronas is reversed?
I mean, the order of operations still has to operate how it does, but we're going to have to force certain things using parentheses and whatever else.
Didn't we do? Oh wait, we did if-then statements.
Yeah, so the then is just keeping your order.
Oh, okay.
So if then more deals with like transitive properties and things like that. Like if A is bigger than B and B is bigger than C, then A must be bigger than C. That sort of thing.
Except we're doing inverses of those.
So what we're hypothetically saying right now
Good afternoon, Gauge Gaines and Piper Betts. Please come to the office. Gauge Gaines and Piper Betts. Please come to the office.
is f of -1. So go ahead and write this out, please. That is the inverse of f of x, is how we say that, not the inverse of f of x. Yeah, I've heard people say it in interesting ways. Inverse of f of x.
Like f to the negative first x.
Yeah, like, and that's not really what it is. It's the inverse of, which the negative first power of anything is the inverse of what, like, it's. But we don't need to go down that road.
Learn something new.
So what then would the equation be? I want to see if we all write the same thing. So what would you fill in here? What is this function? We just said subtract 4, then divide by 3. How do we write that? So Owen's hypothesizing
I'm hypothesizing.
this.
Yeah, but then we should each write something by ourselves.
Ryan thinks we should add parentheses there.
Yeah, sure. I think we actually.
Yeah.
I don't think the variable should be x because x is the input and this is the output.
So this is also where it gets really, really, really tricky. X is always our input, right? Unless we've determined a different input. This is still saying when I put a value into the function, this different function than what we just dealt with, it's going to do this to the input. So it's not acting on an output. We're just now switching places. What's the input? What's the output? Which brings up an interesting point of how we can get to an inverse function. So all we're really doing here, switching places, right? We don't actually switch. We don't actually switch that this, like, we're not putting in an output. Like, please do not think that all because we're changing order. This input is still an input, but everything that happens to it is the inverse of what was f of x. So, yeah, we're going to keep moving on. I don't want to give you that trick yet. I want to see if we can develop that strategy on our own. So try this. So Kimberly's applying for a job. We now have the function g of x, and she has to evaluate how to find the inverse.
The recycling department.
She has to do the math. Recycling's fascinating. Look up videos about how recycling works. It's really fascinating.
Why?
Maybe your attitude's getting better.
Ooh.
Yeah, that too.
Oh, you're not helping. I'm very much helping
Also,
myself.
I left my orchestra folder at home, and I'm really mad.
Ah, G of x.
Your CSY folder?
Yes. I'm sure I forget it. I'm gonna not have to use it.
Does anybody else play the same part as you?
Yes, but then we have like
I'm sorry. I think
But
it's,
see, we have like 3 pages, and we can't turn in the middle of the orchestra like song, so we have to have 2 of the same. So we have like one. First page and then one second.
So while I appreciate that is a genuine concern, can we do this right now? Like, I agree with you. That is annoying that you don't have your music. That is annoying. So this has 3 steps. We're going to multiply the input by 5. We have to subtract that value by 8. And then we have to divide that value by 2. And then we're going to have to figure out how to write the inverse of g of x. Everything in the reverse order. What do you think?
I don't know if you need to add the parentheses on the numerator. I don't know if that's necessary.
So I love that you just asked that question. How we say that mathematically? Anybody know how to say these values are contained within parentheses, but without making it all that complicated? Quantity. So we would say quantity. Well, what are you trying to put in the numerator?
That would be 5x minus 8.
Whether we're going to put the parentheses there or not, you're just saying that is together. So you would say the quantity, 5x minus 8, divided by, and you kind of just take like a pause in your explanation. So if you're verbally explaining to somebody, you'd say the quantity of, and what that means is with or without parentheses, that is grouped together. We can write them here, but they're not necessary. Because the numerator is going to happen first, regardless. Then what goes down here?
Just divide by 2.
Try to write the inverse function on your own by processing it in the inverse. Oh, yeah, what's the output? Sorry, we forgot to answer that first. What is it? This? You keep saying it really fast.
3.5.
Because then we need to verify if we set up an inverse function, if we put in 3.5, my output then is 3. We were just discussing in the last slide that we're really just flip-flopping the input and the output. Right, like that, the inverse essentially just says, okay, now if I switch places, this has to still be true. So, if I go to flip-flop my input and my output, what if I just literally flip-flop my input and my output? No?
It's just going no.
No, because you're just getting a completely different number because it's like the same operation on a different number.
So still, we can't read this as saying the input is something working with the output. You can't, because you don't have an output without already knowing the input. So we need to isolate the y. Now stick with me. I'm just hypothesizing here. Right? We're trying some stuff out. If I need to isolate the y, what would I do first? Multiply by 2 on both sides. So then I'd have 2x. Right, then what would we do?
Add 8.
Add the 8. Ah.
I mean, except when you're really solving, that wouldn't make sense. You're doing multiply by 8. So.
That's how you can get your inverse function really easy. Did we do the opposite operations in the opposite order? We go up instead, and we do the opposite of everything that happened, the inverse, right? So instead of dividing by 2, I multiply the input by 2. Then I add the input by 8, or like add that quantity by 8. Then I divide that quantity by 5. Is that what I did? That works. When trying to write out your inverse function when given the function, you can just turn your f of x, g of x, whatever you got, into a y, flip your x and your y, and then re-isolate the y, and you have created the inverse function. But you really just have to think about it's doing the inverse operations in the inverse order. Sorry, I left. It sounded like this was on. Maybe my TV has something on. Mr. Schur was at that concert. Did you go to the concert last week? Yeah. Because he was there for Run the Jewels.
Oh, of course he was.
His wife's in the Lord.
Yeah.
So you should like go up to me like, hey, heard we're concert buddies.
Yeah, I got confused because I'm just like, Mr. Schur wouldn't want to see Ford.
He said he was just like, okay. So we make sure you have it formally written out. We just said that g inverse of x, so the inverse of g of x, is, I forget what we just had written.
2x plus 8 over 5. No, 5.
Instead of divide, multiply. Instead of subtract, add. Instead of multiply, divide. Make sense? Oh, and try it. If we plug in our 3.5 that we had just gotten, this better work. Try these. So the one reason that I want you guys to be aware of that little trick of flip-flopping the input-output is it's very easy to do this in the wrong order. Like, order is very particular. Gentlemen, you listening? Because it's normally the people that pay half attention that do it in the wrong order. Are those new glasses? I like them. I've never noticed like the blue. You always sit really far away.
How come you never bring your book and you go to these tests? Because she uses mine instead. So make sure that you're paying attention. The order is real easy to get tripped up.
What should the inverse function of n of x be?
Oh. I understand now.
Because this y is
Why though?
Get out.
yeah.
Money.
So what is it?
X plus 12.
Quantity x plus 12,
Quantity.
all divided by 4. Check and make sure that you got that. Then without going through the entire process, if I just wrote out
Do we distribute?
10 y plus 7. 10x plus 7.
careful, always operating on the input. So
That's
10x plus 7.
That's fine.
Your function always has to be given in reference to the input value. So unless your input is like time or anything else like that.
First time, and I thought that was weird, so I just erased it. I don't know why.
So here's how you check. If I made this x equals y minus 7 over 10, sorry, my 7 looks awkward, I'd have to multiply by 10 first, right? Then I'd have to add the 7. Multiply by 10 first, then add the 7. Because the original function first subtracts and then divides. We have to do the inverse in the inverse order. Make sense? Yes? Cool. Alright, this one's tougher.
Oh, great.
Now, if you have the formula for this memorized, don't use that. The temperature conversion. So, Anissa's going to Japan, and she asks her friend how to pack, what's the temperature going to be. Now, the rest of the world uses Celsius, whereas we're stuck with Fahrenheit.
Because we're annoying.
Fahrenheit's
So
better.
her friend tells her it's going to be as high as 30 and as low as 25. And first, Anise is like, get the parka. And she realizes, wait, that's Celsius. So it's not like it's going to be below freezing the whole time. It's the rest of the world, not America. So
That's why we're
how
doing
could you generate the conversion formula for getting from an input of Celsius to an output of Fahrenheit? Knowing water freezes at 0 or 32, and water boils at 100 or 212. So try it out.
Water boils
So
out.
So does it matter which one we use it or input or output as long as
So
it
you
stays
want
the
to
same?
say
Oh, wait, you're
the
trying
so at the end, your goal is to have the Fahrenheit temperature with an input of Celsius, and actually you could just say F of C.
Okay, so C is our
Yeah, you're gonna
I
have
realize
like what
that
happens to
we're
C.
translating Fahrenheit to Celsius. If we're doing Celsius to Fahrenheit, I'm guessing it would be the other way around. So, yeah.
So this is one of my inputs outputs, right? X and Y, and this is one of my inputs outputs, X and Y, or C and F.
And they all should be the same. Like they're the
Yeah, no matter what temperature you put in, it should work.
I can't hear you. What's you?
You go see 3D movies a lot. What? You go see 3D movies
Say, let's go blind dates.
I don't like 475 turns.
What does the point 032 tell us? Because like input output X Y, I mean that's essentially a point in ordered pair. Chris, Y intercept. Okay, so well, that tells me then
We know that it has to add.
so we have to have an addition of 32. Right, because when my input is 0 and multiplication, division, whatever to my input doesn't affect it, I have to have 32. Okay. So then what do I do?
Then you figure out like
Colin, because you raised your hand.
So, so you can then subtract 32 from 212 to get 180.
Why are you doing that?
Because we're gonna have to add 32 to get 32 degrees Fahrenheit for 0 degrees Celsius. So that means that if we subtract 32 to like counteract that, we get 180 from 212.
We're used to using A as our coefficient value, right? So if I say that there's some multiplier A that then will add 32 and get our final answer,
1.8 is
improper. Go improper. It's better.
all right. 9 fifths.
9 fifths.
why couldn't you just look it up?
9 fifths.
I don't understand why she really just look it up.
So Friday through Sunday, I had 0 internet, 0 Wi-Fi, 0 cell service. Sometimes you can't just look it up.
What were you
So
doing?
tired of your generation just saying Google it.
You're a millennial. Gen X
We get that from your generation.
Okay,
telling us
I'm not
to
100% sure that I'm a millennial. That's still out. That's for argument's sake. Depends on when you're born. Like what generation do you fit into. But regardless,
How old are you? You aren't like a
Me?
millennial.
About
What am
28,
I?
29.
Yeah, you're
right?
What am I?
Gen Z.
What's Gen Z?
That's what we all
The
are.
next generation.
The reason we say that
My
everything
sister
Well,
is
why
like
can't they?
technically
because we did not
Get it,
consider
Gen
somebody
Z,
saying
because we're
go
Gen
Google it or
Gen
Well, I don't know.
Yeah.
I want you to use your brain when we can.
All
Alright, so hold up. We got to convert these temps. Convert your low temp and your high temp then. Wasn't it 25 and 30?
Yes.
So those are your input values.
Oh, 25 and 30 as an input value.
Yeah, to get the Fahrenheit temperature so she knows how to pack.
Oh my. That's kind of cool. That was the formula, but I can't do it in my head all the time.
One of my friend's favorite stories about his dad is when they were being like little twerps in a restaurant and he needed to distract them or get them thinking about something. He told them that there was a way to manually get the formula for converting. And the kids were like in high school or whatever. They were old enough to understand this. And he made them on a napkin. He said, like, if you want dessert or something, I forget all the details of the story. He said, if you can figure out the conversion formula for Fahrenheit, Celsius, or whichever direction,
You get something.
yeah, like I'll buy dessert.
That's a good thing to do.
I'd do that.
Because, so this is really cool, right? All we had was 2 points. Now, the other thing that we know is it's linear. It has to be a linear relationship because it has to be consistent, right? This direct conversion. But now we need to turn it around. Now her friend from Japan is going to come and visit California, and she needs to be able to convert Fahrenheit temperatures into Celsius. So how do we write the inverse? By the way, I wrote your answers up here if you generated those from your inputs. How do we write the inverse of this function? What do we need to do first with the input, Ethan?
Subtract 32.
We're going in the reverse order with the inverse operation. So subtract 32,
And then divide by 1.8.
then divide by 1.8.
Multiply by 5, 9.
Multiply by the reciprocal.
Oh my gosh, I forgot about that.
So we
There's a
normally,
negative
hold up,
on the one.
we normally write this as 5/9 quantity x minus 32 because still this happens first.
Ethan.
What are you asking about?
negative 1.
Oh, sorry. Negative 1.
That was point. I was working.
Stop.
The point
You
one
know what
there.
it's supposed to be.
No.
All right, ladies and gentlemen, are we good with understanding? Now, we could write this. I'm not saying there was anything wrong about that. We could write this as x minus 32 over 1.8,
Don't do that.
which is fine. But that's just not normally how you see it. Because they want you to recognize 9/5 compared to 5/9. Add 32 compared to subtract 32. But here the subtraction happens first. There the addition happens last. So again, inverse order, inverse operation. Cool?
Yeah. Be gooch. Okay.
All right, we're back at recycling. Ambrosia.
More
And
interesting.
should get a better job.
I think recycling is a really
What is up with the whole thing with quadratic
I don't know. I think that was like a weird chop from the book.
She's a medical writer.
So, what would be the inverse function of h of x?
Got it.
Oh wait.
Anybody?
Okay.
X plus 1.
Ooh. Careful. I heard a couple minus ones. X plus, sorry. X plus
Okay, I thought you were
1.
thinking you were like, I heard a couple plus ones.
No, I heard a couple minus ones though. Inverse operations, inverse order. Right? So we add the one first, then divide by 2. You may parenthesis or not. Up to you. Right. When you're saying it, you read it. So, moving on. Let's graph this real quick.
Wait, do we have to graph it by hand, or can we type it?
I mean, I guess if you go ahead and throw it in your calculator. But if just make sure that if I ask you to graph it by hand, like on Mastery, you'd be able to.
Yeah.
So, if we look at this, like in Desmos, then.
I think you did this one. Okay, can you just do the regular, not put the inverse in it?
Yeah, you can.
What?
So,
And you can just do like this.
So I'm glad you asked that. Jenny,
Put it in parentheses.
all you care about is each function is saying the output. So my one function initially is.
That's not, okay, no, and I missed it. What?
Are you saying just in the calculator how you can type it in or what?
Yeah, no, I got it. It's fine.
Because we can just keep saying y. So now this is the inverse of h of x. Will be quantity x plus 1, quantity divided by 2. So wait, what do we...
Oh, is it across the line of x equals y equals? Wait, never mind. I think it's the other way.
Oh yeah, isn't there like one point where it's like the same?
Is there x equals the absolute value of y? Maybe it's like reflecting across. Because if you look,
They are
just
inverses,
y equals
so.
x. Just y equals x.
Inverse functions will always reflect across the line y equals x. Now this gets kind of mind-blowing when we look at more complicated functions, which we're about to embark on, but somebody at the beginning of class said, yeah, it's like you have a square root compared to a square.
Excuse me, could I please have Renard to the office, please?
Oh.
Now, the one issue is there is no range for the domain and the negative because it can't do that, right? Those are non-real numbers.
Yeah.
But you can still see in the quadrant where it does exist, we reflect on the line y equals x. We can also do this for more complicated functions.
No.
Fun.
Yes, yes, yes.
No.
And actually, it starts to become easier to just use fractional powers. So, cube root would be
Whoa!
I know
Wait,
exactly
question.
what I should've
I was
done.
thinking great. Here's a weird question.
yes.
Can we
Oh,
make,
it's-
can we
it's
make
like
something
something
like
else.
DNA, like,
It's a
like
mess,
swapping
guys.
sides?
Fine.
If we do it like something to the 9?
You have full-on access to Desmos.
Yeah,
I'm
use
going to
this
leave you
here.
wondering that question. So, just wanted to show you that reflection.
That's so cool looking.
And that's what you would see here. I know you guys are accelerating, can absorb information faster, and we're running out of time, so that's what you would see from graphing that stuff. A quadratic inverse, we just want to talk a little bit about this. So if the function was, I believe it's x squared, for some reason there's just some gaps in this. Yeah, so if the function's x squared, you know, the inverse of squaring something would be the square root of it, and it turns the function sideways. Now, technically, this, okay, it's hard with Desmos because Desmos isn't going to show you the, how do I even explain this? No, I'm trying to think of what I can graph up here to show you guys.
You can graph x to the million.
Wait, no, what is that?
We're not going to see that.
We're not gonna get that and zoom out very,
So,
very far.
hold on. If we're just talking square roots, this function, you know, goes right here, but then it does not go out here.
Yeah, because
Because you
it's
can't have a
negative.
straight of a negative.
It's imaginary.
Yeah.
It's always there,
Oh,
but
so
it's
you
just
can't
like a-
visualize and imagine.
It's wait, does it make one of those 3D graphs?
This is
Yeah.
this is just the x equal the x squared graph, but it's
Wait, come here, I need to see.
Jenny was almost right there.
oh, so I actually said something that makes sense.
Because remember what we said, guys, to manually do this with the formulas, you just switch your x and your y locations. Hey, gentlemen, come on, focus up. So if we just take this initial function and swap around your x and your y's, you actually get this yellow function,
Which is a perfect.
which then creates a disagreement, right? This section is not reflected. Or is it?
Wait, what? Is it just
This
Yeah.
bottom section, is it a reflection of this?
That's just the reflection of the square root.
it's no, because it's reflecting across the
This, so what I'm asking is this red line and this yellow line, are those a reflection of each other? Or are they are they a reflection across the green line?
Yeah.
Yeah.
Well, can you
Yeah, they are.
can you visually do it?
They are, I just did it.
So if you draw lines perpendicular, right, it's supposed to do the same distance,
It is.
those reflection rules. This is. So while this, the blue, doesn't show the bottom section for the yellow because it creates a disagreement with domain and like what you can actually physically do. When we think about the inverse, just flipping places, we can graph this whole thing. And it actually depends on what graphing utility you use, whether it will show you that section or not. Because this section is part of y equals square root of x. It's just not going to be shown depending on the utility.
Wait, can you do that on your
So,
calculator?
yeah, so blue and yellow are exactly the same. Right? If I square root both sides here, I
Except
get
the
y
blue
equals
doesn't
square
have
root of x. Except this doesn't show it
on the-
based off how it's typed in. So we got to keep moving on. Sorry, we got more to cover. So here's the problem. What's the difference between yellow and blue?
Yellow
This is
shows
negative.
both negative. Yellow has the negative range.
Okay.
It shows a negative range, and the blue one doesn't.
No, it shouldn't. That shouldn't be.
Purple. I don't want purple. Which one the blue and yellow be green? It's not green. It's brown.
Nobody?
Nobody what?
One has a square root, one has a square.
Why is
I
the
mean,
yellow going
it's
negative?
opposite. It's inverse.
Is
I mean,
yellow a
if you-
function?
No.
Blue, would it just be considered?
That's why blue doesn't show the bottom half. That's why when we graph the square root of x, we only end up seeing this. Because if we're trying to call it a function, it has to pass the vertical line test. And realistically, we know if I put in 4, I can only get out 2. Right? Square root of 4. But really, hypothetically, mathematically, I could get out negative 2. Right? Like negative 2 could have been the number that when squared makes my 4. But that doesn't work for the function. So, while x equals y squared shows the entire thing, that parabola kicked sideways instead of upwards, this is the function square root of x represented here because you can only show where the domain and range allow it to be a function. Does that make a bit of sense? Vertical line test. That was the biggest thing I was trying to get us to remember is vertical line test. That makes it not a function. So then our f of negative 1 of x, so inverse of f of x, we got to restrict it. So please with me. We said it is square root of x. But when x is greater than 0, right? Greater than or equal to, I guess we could probably say. If we have a domain restriction on it. But still, our range, and this doesn't really ask about the range, but we know the range also ends up all positive values. Like, it's only above the line, if we're making it a function. Real quick, inverse of p of x.
The square root of
Yeah.
Square root of the quantity of x minus 2.
You have to have it subtract before its square roots.
Would you distribute first?
Good.
Okay, I'm just doing that to help me.
So it's the quantity of x minus
X over 2 minus
Plus
x
3.
plus 6. Wait, no,
X.
minus
No, plus.
So
The
it's
quantity of x plus 6 over
Over
2.
over.
Space.
And we look at this two different ways. First thing that happened here was x gets subtracted by 3.
X plus 3 divided by 2, right?
But the other way we can x
The
plus
quantity
6
of
over
x
2.
plus 3 over 2.
So you go in order of operations. First, this subtracts 3, then it multiplies by 2. So we need to go backwards. First,
So
we need
divide
to
by 2,
divide by 2
and then add 3.
and then add 3.
Oh.
Will that be the same thing as if we work with that? If we say,
X plus 6, the quantity of x plus 6 over 2.
No, because that's a. You have to make that a positive 6 then. If you want to.
this is where if you distribute, you could distribute and say this is the same as that. For working to get your inverse, leave it how it is. Think about order of operations. Okay? We're totally out of time, so we gotta get out of here. Thank you guys very much. I think that was, yeah, that was everything.
Actually, that fraction.
Do what?
This one's like very, very nearly.
Yeah.
Like actually, basically.